Hey good folks, I'm Ben here for Tats Plus, and welcome to my lava lamp tutorial. In this tutorial, we are going to use Maya and Realflow to create a simulation of wax floating up and down inside a lava lamp. The main focus of this tutorial would be the Realflow simulation. So as you can see, I've already went ahead and created the mesh for the lava lamp. We've got the base here and the lamp itself, the glass part. I created those using a CV curve tool. So for example, if I'll go to side view, create CV curve tool, and I'll do this real quick, nothing too fancy, just to let you know how I used the CV curve tool to do this. So let's say that's the profile of the base. Once I have my profile set, I can go to Surfaces, Revolve Options, and I'll make sure I'm creating polygons and triangles, and I'll hit Revolve. And it's a bit too wide. The reason for that is that the axis Z is in the center of the grid, so let's move the pivot here. We'll hit Insert, and we'll snap the pivot using C to the end here. Okay, hit Insert again, and let's hit G to redo the last command, which was Revolve. And there's the base. Well, of course, it's not nothing too pretty, but that's the general idea of how I created it. So let's get rid of this. Get rid of this one too. And once we have the model ready, we need to export it to Realflow. And I'm only going to export the lamp, the glass part, since the simulation will occur inside it. In order to do that, I'll switch to my Realflow tab and go to the first button, the SD export. Make sure the mesh is selected, and I'll hit the SD button once. And make sure you're not using a playback range and you're only rendering one frame. And we need to name our file. Let's see. We'll place it in the objects folder. You probably don't have yet all these folders, and those folders will be automatically created once you create the project inside Realflow. So anyway, we export the lamp into the objects folder as an SD file under the name lamp. Hit export. Now, if you haven't installed the Realflow for Maya tools, you can always export this object as an OBJ file. Go to File, Export Selection Options, and choose OBJ Export. And then export selection and export it to the location you want. If the OBJ export option isn't available, you need to go to Window, Settings and Preferences, Plugin Manager. Somewhere around here is the OBJ export. There it is, OBJ export. You need to make sure it's marked. However, I remind you once more, you need to have your mesh triangulated in order to import it into Realflow. So let's jump into Realflow and let the fun begin. Okay, so here we are inside Realflow. Let's go to Import, Object. In the Objects folder, we have the lamp. We'll open that, and there's our mesh, and it also imported the camera, which we have no need for. We can delete that. Hit 8 on the numpad to switch to the wireframe mode. One thing I haven't mentioned, which you need to take into consideration. In the grid in Realflow, every square is equal to 1 meter on 1 meter. And in Maya, well, that depends on how you set it up. If we'll go to the preferences here, we can switch to settings. At the moment, I'm working in centimeters, not meters. You need to keep that in mind when working in Maya and Realflow. In Realflow, it would affect the simulation, and in Maya, it would affect the lighting. So, switching back to Realflow, the way we are going to set up the simulation is as follows. we're going to create a sphere, fill it up with particles, and then we will need to attract, push, and pull those particles with different opposite forces. So first we need to create a sphere which will contain the particles. We'll go to the object menu, which is this yellow square here, and we'll create a sphere, which is created at the middle of the grid. Place it somewhere around here. Let's see. By the way, by hitting 1, you can switch to the top view. 2 is the front, 3 is the side, and 4 is the perspective. So let's switch to 3 to see that we are in the middle here. And yeah, this is a good place for our sphere. And it's a bit too small, which means it won't contain too many particles. So we can scale it up a bit. Let's see. In the nodes section, I'll set the scale to 2 by 2 by 2. And this way we'll have a little more particles going on. Since the sphere is inside our lamp object, all the particles will be trapped inside the lamp. So next, let's go to the particle fluid menu, which is these 3 blue dots here. And we need to create a fill object and a container. Okay, so we got a fill object and we've got a container, and those two would swap the particles between them. First, the fill object. We'll go to the fill object section on the right, and here we've got object. We haven't set any object here, so we'll just click on it once and choose the sphere and hit OK. Nothing happens at the moment. Actually, you know what? Let's hide the lamp. Control H to hide so we can focus on what's going on here. Okay, so fill object. We've set the sphere, but nothing happens. So we need to check fill volume to yes. And now immediately we get particles inside our sphere. Now let's check out some of the properties of these particles. At the moment, at the way they are set up, these particles would simulate water. And we are not simulating water. We want to simulate wax, or more accurately, heated wax floating in oil. So we need to mess about with these settings a bit. First, we'll set the resolution to 5, which will increase the amount of particles here quite a bit, and we'll have a more accurate simulation. We'll set the density to 850. We'll set the viscosity to 2, which is counter-logical since we do want a very highly viscosity liquid here. But we would also change the surface tension, which would cause the particles to really stick to one another. We'll raise it up to 1000. That's our initial particles. And for now, that's it for the fill object. Let's move over to the container. And we need to have the same settings here. So actually, you know what? For the time being, I'll leave it at 1, and I'll also change the fill object to 1. And the reason I'm doing this is because I want to show you a quick preview, and having the resolution at 5 will take a very long time to render. In the container, we'll leave the resolution at 1 and we'll set the density to 850, viscosity to 2, and surface tension to 1000. That's it for the container and the fill object. Now we'll start adding forces to the scene which would drive the particles. We'll go to the daemon menu and we'll need to create a filter daemon. We'll duplicate it 2 times, Ctrl D. These daemons are in charge of swapping the particles between the fill object and the container. So let's start setting those up. We'll go to filter 1 and we'll tell it that the source emitters is the fill object and the target emitters is the container. So we're telling it, take the particles from the fill object and move them over to the container. But under what conditions? Well, under the condition of lower than 1.7, but 1.7 what? Position Y. So all particles which are lower than 1.7 in position Y, move those particles from the fill object to the container. Wonderful. Now, let's go to filter 2. In filter 2, we need to set the exact opposite. The source emitter will be the container and the target emitter will be the fill object. And the condition is greater than, not lower than. We'll change the attribute from speed to position Y, and we'll change the value to 4.8. Inside the lava lamp, at the bottom, you have an actual lamp which is heating up the wax and causing it to float up in the oil. And once the wax is reaching the top, it gets cool enough to fall down. Since it's floating in oil, it's very slowly, but once it gets closer and closer to the lamp, it gets heated up again and then floats up. So we are trying to simulate the same conditions here. And last is the third filter. Again, the source emitter will be the container and the target will be the fill object. And again, greater than, and we'll leave the attribute at speed. We'll change the value to 1.3. Now, you may be asking yourself, how did I get these numbers? Well, I've been experimenting very, very long. It takes a whole lot of trial and error until you get the numbers just right. I really do encourage you to experiment on your own with different values and see how it affects the particles. Next, we need to create a few more forces for our scene. We need to create a gravity. So again, I'll go to the daemon menu, gravity. Let's move it aside so we can see what's going on here. Actually, let's look at things from this point and let's move these filters. Their location doesn't really matter. This way it would be a bit more clear what's going on here. We'll set the strength to 0.8. So we've got a very low gravity pulling down the wax. Let's rename this gravity. Right click and choose rename. We'll rename gravity to gravity down and we'll duplicate it, Control D. Rename the duplicate to gravity up. Let's move gravity up a bit upward. Again, it doesn't really matter where it's located in space. These icons are just indication of a force that's working in the scene. Its location really doesn't matter. Let's switch to node and we'll rotate it on the x-axis to 180 degrees. So this is up, this is down, and we'll set its force to be a bit higher than the downward one. We'll set it to 1. We'll need to create another daemon. Let's go to the daemon menu and we'll choose the drag force, which will just generally help slow things down here. Now, after simulating and experimenting with this quite a bit, I can tell you that between the fill object, the container, and the two gravity daemons, the particles tend to get stuck at the top and at the bottom. So we need to give them a little push to prevent that. To create that extra push, we'll create a wind daemon. So we'll go to the daemon menu and there's the wind. We'll bring back the lamp so we can see what's going on here. Control-Shift-H to bring it back. Just to be accurate, it was always in the scene, it just wasn't visible, but it was active. Okay, if you want to deactivate an object or a daemon, under node you need to go to simulation and set the active to inactive, but we do want it active and visible at the moment. So wind, let's see. Rename this one to wind top. Let's switch to side view, move it over to the top here. As you can see, it blows down. And let's change some of these settings here. We'll set the strength to 1.5 and we'll set the bounded from no to yes. And now we have sort of a cone here. The wind now doesn't occur through all the scene, it just originates from this point and blows down from this cone. This is the top radius. If I'll change it, you can see the top is changing with it. Let's set it back to 0.5 and we'll set the bottom radius to 1. And one other thing, we'll change the height to 2. Now you might need to play around with the position of the wind. Let's duplicate wind top, Control D, and we'll rename this one to wind down, or actually bottom. Okay, so this is wind bottom, and we'll drag it down, and we need to rotate it in the node section on the x-axis to 180 degrees. Again, pull it down. Let's switch to side view by hitting 3 on the numpad, and let's see, the strengths should remain the same. We'll change the top radius to 0.8. Well, it's reversed now, but it still is the top radius, and the bottom radius to 1.4. Now, this section here won't be rendered in Maya because it's hidden in the lava lamp base. Okay, so we've got quite a bit of demons here in our scene, and we got one last demon we need to create. Let's go to the demon menu. We need to create a kill isolated demon, and for no reason we'll just place it here. Now, kill isolated will be in charge of killing any small particles which would get separated from the big clusters, and kill isolated is based on time. We'll set the time to 0.5. So that's it for our scene setup. At the moment, we have a fill object and a container, 3 filters, which tells the particles to run between the fill object and the container, and we've got a whole bunch of demons that's attracting and pulling the particles from both sides. But at the moment, all the forces are affecting everything together, and in this way we won't get the result we're after. Over here in the nodes section, we've got all the objects and forces that's working in our scene, and below it we've got the global links. Everything in here affects everything in the scene, and what we want to have is different forces being applied on different objects in our scene. So what we need to do is use the exclusive links. Let's click on the square here, and here's what we need to do. We want some forces to apply to the container and others to apply to the fill. Some forces should apply to both the fill and the container, and obviously some forces shouldn't apply to the container and others shouldn't apply to the fill. So what we need to do is drag the container to the exclusive links and drag the fill to the exclusive links. Let's focus on the container first. To the container, we'll drag the fill object. Just drag it on top of the container. Next, we'll drag in our drag force. We'll drag gravity up to our container. We'll drag wind bottom to the container. We'll drag the kill isolated, and obviously we need the lamp itself. That's it for the container. Now for the fill object, we need to drag in the container. And let's see, the drag force, the kill isolated, the gravity down, the wind top. Drag those inside our fill object, and of course the lamp. Now that our exclusive links are all set up, we can delete everything inside the global links. So the relationship between the forces, the particles, and the objects is determined by the exclusive links. Now notice that even though the sphere object still is in the scene, and even though it's still active, since it's not in the exclusive links, Realflow will ignore it, and it won't interact with any force, particles, or objects in the scene. Now, before we start our simulation, our scene is complete, but we need to set up some things here. We'll give the timeline 3000 frames. Next to simulate, we've got a drop-down menu arrow. We'll click on it once. The recording doesn't get it, but there's an options button here. Let's click on it, and that will pop up the simulation options. By default, the frames per second is set to 30. And since we're trying to render something that happens very, very slowly here, we'll set the frames per second to 100. And we'll set the minimum substeps to 10. We'll hit OK, and we get a warning which we can ignore. Let's hide the lamp. It's still in the scene and it's still active, and we can also hide the sphere. The sphere is in the scene and it is active, but since it's not in the exclusive links, it's not influencing anything. And we can easily now focus on the particles. In the display section, I'll set the fill object. I'll leave it in blue, and I'll set the container to something else, let's say green or red. Okay, so we can tell them apart. Okay, let's start the simulation and see how it goes. So here we are after plenty of repeated simulations, adjusting the parameters, simulating again, adjusting the parameters again, and so on and so forth. I finally got a satisfying result. Let's see how it looks. Not too bad, right? Not too bad at all. I made a few changes to some of the parameters and we'll run through them as we go. First, if we look from the side view, I've moved everything a bit below the grid surface. Actually, I placed it in the middle of the grid. At the moment, we are looking at the fill object particles. Filter 1 tells us that once the particles are in position y of minus 1.7, they would become container particles. Let's see how that looks. Once the particles reach 1.7 at this point, minus 1.7, they become container particles. And once they do, these forces, the gravity down, the wind up, no longer affect them, and they are getting affected by the gravity up and wind bottom. And once the container particles reach the value of 4 in position y, i.e. this point, they become fill object particles, and the opposite action happens. The gravity up and wind bottom no longer affects them, and the gravity down and wind top do affect them, causing them to fall down or pushing them down. We got filter 3 that indicates that once container particles reach the speed of 1.3 in combination with filter 2, they become fill object particles. It might be a bit confusing, but after experimenting with it, there's no doubt you would get it. Just play around with these settings and see how it affects the particles. And this brings to the conclusion part 1 of this tutorial. Join me in the next part, where we would build a mesh out of these particles, import it into Maya, build a shader for it, illuminate the scene, and render.